kind of demo here. So I didn't make this globe, first of all. This is something that was made by the WAG Institute, which is part of the City SDK program. It's out of Netherlands. That's right. That's right. So the Europeans are starting to standardize the way that they organize all the data so that they can plug it into tools such as this. And I'm pretty familiar with their City SDK visualizer, which is kind of starting with this, but there's some limitations in it, but it's a good start. So basically, they're allowing you to, zoom to different things, and you click on buttons and have one collective place for all this data. And now the discussion starts of like, okay, well, how does this actually differ from a Nokia here, or like a Google Earth and that type of thing? I'm not going to get into that right now, because I think there's a place for things like this, and there's a place for Google Earth too, I think. So we'll zoom into Chicago again, and here's that same view. And this one actually has something that the DSSG group was helping with as well. They were basically taking census, the loads data, which basically is the origin destination data from block to block. And they made this, right here. They made this awesome importer of all that data. And
what's the data?
The census, loads, origin destination data.
Or origin of what and destination? Like what's moving?
I think block to block. You guys know this.
Yeah, it's where people live and where they work.
Oh, people going to work.
Right. Yeah, live and work.
So for every census block is where everybody's coming from to work in that census block, and then people that live there work there.
And then type of jobs that have how much money they have.
Right.
So maybe you see a census block downtown have, flows from all over the city, and then places, more outlying blocks maybe are mostly related to each other or things like that.
Yeah.
Is that done every year?
Every
time?
I think it is every year.
It's contributed to by the states.
It's every year.
And
Every year.
it's only
Pretty nice, yeah.
there's 2 states that don't contribute though.
What are they?
Massachusetts and New Hampshire.
It's a survey, right? They actually don't
No,
go
it's
around.
based on the tax.
But it's a pretty refined data set in terms of like it's updated every year instead of like 10-year census data. It's like pretty nice.
It's quite a bit of data too.
So basically, these guys made an awesome importer to Mongo database and an API, a REST API. Even though I'm not using that.
Still
right
working.
now. I made one in Node.js that basically you can make a call through the URL from this particular tract, and it will tell you how many people are flowing into that tract and how many people are flowing out. So I can click on a tract here, and we're sitting. I think we're right next to this one. I'll click on this one, and it actually maps through like arches here in this case, the number of people going out, which is in blue, and the number of people going in, which is in red. And so, who just said that you go out and you'll see, like, as you go out to these, they're more locally defined. That is exactly the case. It's much less. I mean, here's the downtown loop, and this has the highest, the highest amount of activity and migration in and out. As you go further out here, there's a lot going on over there. It varies a lot, I guess. That's what I'm saying. So great. What is the point of this data? At least from my perspective, in the planning and design realm, I'm starting to use this kind of data to calibrate a transit model. Basically saying that, okay, if we had to simulate cars on these roads and and L trains going to and from work, and we wanted to put them on a schedule throughout the week. And we want to actually see these cars going, and I want to click a button and have it go, play the week off. This data is actually used as like a calibration source for that. So I would actually say, okay, from this point to this point over here, send 5 people going to work, and 3 of those people will take the train, and 2 of them will drive, or whatever the mix is going to be.
So it lets you tune your simulation.
What's that?
It lets you tune your simulation.
It's gonna calibrate the simulation, and the specific simulation is an agent-based model. So each of these little individual cars or people on the train or whatever they're actually they're individual agents with its own set of rules and its own set of behaviors. They're being processed on a computer somewhere, and they interact with the other agents, and they say, I want to get to that point, to that point. What's the purpose of this kind of stuff? You can say that, well, if we close this road and we close that road, how would the the commuters respond in that case, or how would people respond in that case?
So it's an example of, so the agent is a vehicle.
I'll show you an example right now. There we go. Oh, shoot, it quit. There it is. Oh, sorry, it did quit.
Is that your simulation of the galaxy?
Wow, so realistic.
Hey, you mean about
that's
$1,000 per
Argon's
hour?
doing that. Argon's doing that. What's that?
I see what you mean about $1,000
Yeah.
per hour.
So actually, some of the collaborations going on right now are going to be with Argonne National Lab, and we're going to be hopefully soon firing up some of their supercomputers to run that type of scale analysis, individual, simulating individual cars and people moving on the trains and back and forth. And if I close a road, it will automatically update, and it's all going to be wrapped in a parallel scripting language from the University of Chicago called Swift. If anyone's familiar with it, it's pretty interesting. It has similarities to Node.js if you're familiar, but